everybody. Thank you so much for coming to hear my talk. My name is Erica Sosa, and this is what happens when a linguist learns to code. So, out of curiosity, has anyone in here studied linguistics? Oh, okay, cool. Yeah, quite a few people. Has anyone ever taught language? Okay, a couple people. Has anyone ever learned a second language? Yeah, a lot more. Has anyone learned a second programming language? Yeah, even more. Has anyone ever taught coding in a formal setting? Okay. Has anyone ever taught coding in an informal setting, like mentoring? Okay, great. So a lot of different experiences in here. That's great. So today I'm going to compare or explore how learning a natural language compares to learning a programming language. And I'm going to see what we can apply from the field of language teaching to programming instruction. I hope that anyone who's interested in learning or teaching programming languages will be able to walk away from this talk with some concrete ideas on how to be better teachers and learners of code. So you might guess from the name of this talk that I'm a career changer, and I used to be in the field of linguistics. I started this career by teaching English as a second language, both abroad and in the US. Some years later, I got a master's degree in linguistics, and then I went into university teaching of ESL, applied linguistics, and second language acquisition. After many years in linguistics, I decided I was ready for the next challenge, and I decided to go into software engineering. I ended up doing a coding bootcamp where I learned some Ruby and some JavaScript, and then I freelanced for a while doing web development for small companies. Eventually, I got a job at Braintree, where I still work today. The first engineering team I worked on at Braintree was a Ruby team. Then later I moved to a JavaScript team, and I'm still on that JavaScript team currently. So that's to say I learned Ruby as a first programming language and JavaScript as a second programming language. So that was a bit about my background, and now I want to jump into my real topic, which is how learning a natural language compares to learning a programming language. So when you study something or you work in a certain field, a lot of people make assumptions about what you do, and some of those assumptions are right and some of them are wrong. But I realized throughout my career that a lot of people had ideas about language and linguistics, and it turned out a lot of people had more ideas about how language and linguistics relate to coding and programming. Specifically, they would ask me if my background in linguistics helped me to learn how to code. And at first, I thought those two things were completely unrelated. But the more I considered the question, the more I realized that there was indeed some overlap. So initially for this talk, I wanted to explore like every single way that we could compare natural language to programming language. But that is like a really huge topic, and I definitely did not have time for that. So instead, I'm going to focus on a few specific areas around learning languages. So this is our agenda for today. So we're going to go over human versus computer language, first language acquisition, second language acquisition, teaching language, and programming pedagogy. And for those who aren't familiar with the term pedagogy, it means the theory and practice of teaching. So let's start with human versus computer language. I want to talk a little bit about the similarities and the differences between these two types of language. So there are a lot of ways that they do and don't compare, but today we're going to focus on grammar. So when I say grammar, I'm not talking about how your old English teacher might scold you for ending a sentence in a preposition, not that kind of grammar. Grammar in a linguistic sense is the mental system that allows human beings to form and interpret the sounds, words, and sentences of their language. And this grammar is descriptive, not prescriptive, meaning that we're interested in how language is actually used, not how we think that language should be used. So let's go over some fundamental principles of human grammar. All languages have a grammar. So there's no such thing as a primitive or advanced language. All languages are equal because they're all rule-governed systems. All grammars are alike in basic ways. So there are some qualities that all human languages share. So for example, all human languages have some concept of subjects, objects, and verbs. Or all spoken languages have the ah vowel sound. All grammars change over time. So language change and evolution is an inevitable feature of human language. So people who actively try to control speech or the way people talk generally don't win that battle. So an example of this is how now we can say like because plus noun, because reasons, right? We used to have to say because of reasons. And people tell you all day long that you can't remove that preposition, you need the of, but that's not true because we do it. And language change is organic. That's how it works. It's a natural and expected part of the evolution of language. Grammatical knowledge is subconscious. So we understand the grammar of our native language intuitively. We don't need to think about a rule explicitly before we speak because it's part of that mental system of our grammar. So that's to say we have some sort of mental blueprint for understanding language. So this is an article that just popped into my feed, and it talks about a rule of English that's being explicitly taught in ESL classrooms, English as a second language classrooms, and how native speakers aren't even aware of it. So if you take this sentence, or this phrase, a nice new house. If you're a native speaker of English, that sounds like a very normal thing to say, a nice new house. Now take this one, a new nice house. Does that sound weird? Yeah? Okay, a new nice house. That sounds strange if you're a native speaker of English, like you wouldn't say that. And there's a reason. As it turns out, there's an order to the way we place adjectives in front of nouns, and native speakers just know this rule intuitively. You don't have to recall it before you create this phrase. So that rule is opinion, size, age, shape, color, origin, material, purpose, noun. Did anybody know this? Okay, yeah, a few people, wow. How many of those people are second language learners? Yeah, so most. So we can say a nice big old pointy red German wood gardening shed. But we cannot say a pointy German old big nice gardening wood red shed, right? It's funny, it's ridiculous. Okay, but this is your subconscious grammar. So what about programming? How can we take these concepts and relate them to programming? All languages have a grammar. This is true. All programming languages have rules that govern their use. And to some extent, that grammar is both prescriptive and descriptive. It's prescriptive because these are very rigid rules. If you try to get creative with computer language, it's not going to work. Things are going to break. But in human language, we can say, for example, do you like ice cream? We can also say, you like ice cream? Dropping the do is not a problem. But in Ruby, we can't just drop a word off of an expression. We can't drop the def at the beginning of this method definition because it's going to break. But in some sense, it's also descriptive because we can use certain constructions even if they're frowned upon by the community. Right? So in the Ruby world, we want to see the first version. We want to see yummy question mark, right, for a Boolean method. We don't want to see is underscore yummy. But we could still use it. It would be fine. It's not going to break. All grammars are alike in basic ways. So this one is hard to say definitively because there's such a wide variety of programming languages out there. But I did do a little research to find out that most people think that there are some universals, some basic universals to programming languages, particularly the higher level programming languages. And those would be things like conditionals, loops, code reuse or functions, mathematical operations, variables, comparison, and Boolean logic. All grammars change over time. This is probably true. I don't know if we can call it a definitive truth, but what I do feel confident in saying is that human language and computer language change differently over time. So computer languages change inorganically, meaning that someone has to decide to write a new feature, and then others decide if that feature is permissible or not. And then a new version has to be released allowing that feature. Like, I can't just decide I want to do pattern matching in Ruby 2.6. I've got to wait for 2.7, right? Grammatical knowledge is subconscious in programming languages. This is probably false. So no person is a native speaker of any programming language, since all programming languages are intentional human creations. However, someone who knows a programming language particularly well could have an intuition that something was not quite right without actually knowing for sure. So I'm going to give you a chance to look at this Ruby example, and I want you to pay close attention to how this class gets its name. I'm going to give you a second, and if you think it's kind of weird or kind of funny, I want you to raise your hand. Okay, so some people think it's kind of funny. I too think it's kind of funny. So let's go over what's happening here. So what's really happening is that an anonymous class is being created. So we check the name there, it's nothing, it's anonymous. Now here's the weird part. We name that class by assigning the entire object to a constant. And it can only be named like this with a constant, and you can't reassign the object. And then we check the name, and it's WTF. Like, WTF, what's going on here? This is weird. So I'm willing to bet that a lot of Rubyists would not know this intuitively. And I have a little bit of data to back me up in here, because this example was posted in a Braintree Slack channel, and people were like going crazy with heads exploding emojis and stuff like that. So using your programmer's intuition, you would probably think this couldn't be done. So we could say in the case of programming languages, we can't always rely on our intuition to determine what's grammatical, because ultimately it's the interpreter that decides what's right and what's wrong. And by the way, this is not a bug, this is documented. So again, we can see how grammatical knowledge in this case is quite explicit. All right, so that was a little bit about some very high-level commonalities and differences between natural language and programming language. But what I really want to get into today is how we learn both human and programming languages. So first, we need to differentiate between first and second language acquisition. When we say second language acquisition, we're talking about everything that is not your first language. So your second, your third, your fourth, which is to say that learning a first human language is a separate process from learning a second and beyond human language. So learning a first language is a process of exposure, feedback, and inborn knowledge. So exposure, because the more language you hear, the faster you pick it up. And when we say feedback, we're not talking about explicit correction, because that doesn't really work with children. We're talking about the process of interaction and certain types of linguistic interaction yielding other types of behavioral results. Inborn knowledge is the idea that there's something about being a human that predisposes us to language, even if we don't know exactly what that certain thing is. But barring some extreme circumstances, every person in this world will acquire a human language. So can we compare learning a first human language with learning a first programming language? Yes and no. So we could definitely say that learning a programming language is a process of exposure and feedback. Exposure because it requires a lot of practice. Feedback could be coming from another person, but a lot of times it's coming from your errors or your interpreter or your tests. But we'd be hard-pressed to say that there is some inborn knowledge that allows us to acquire programming language. There is similarity between human and programming language in that we're learning to express concepts through the language we're using. So for example, I might be learning about iteration for the first time, and I'm using Ruby loops to be able to express that concept. However, when learning a natural language as a baby, you've already developed some concepts, and you're just learning how to express them. As a human, you're not born with any sense of how to conceptualize software development. So you're learning both the concepts and the language at the same time. So assuming there's a benefit in learning the concepts before the language, can we find a way to decouple concepts from syntax? Well, we're going to put a pin on that, and we're going to come back to it at the end. So now let's talk about learning all of the languages after your first, which is to say second language acquisition. Does anyone in here speak 2 or more human languages? Cool. How about 3 or more? Wow. 4 or more? Whoa. 5? 6? Oh my God. Okay, I'm going to stop. That's a lot. That's great. Good for you. All right, so it's very difficult to come up with a comprehensive theory of second language acquisition because there are so many more factors at play than in first language acquisition. So what is the first language? What is the second? What's the learning environment? What's the learner's age? How did they learn? What's their motivation for learning? Lots of factors. So in the absence of any sort of unifying theory, second language acquisition draws from many different fields, linguistics, psychology, philosophy, and pedagogy. First language transfer is both an interesting and applicable phenomenon when we talk about programming. This is the idea of transferring the features of your first language onto your second language. So the most obvious example of this in human language is pronunciation. So if someone learns a language after a certain age, they'll almost definitely retain some pronunciation features of their first language when speaking their second language. And you could definitely apply this to programming language. So if I learned JavaScript first, I might write some Ruby that looked like this. So I might do these Boolean methods. We already talked about this, is underscore yummy versus yummy question mark. I might use camel case instead of snake case. I might explicitly return out of a method. I might use parentheses in a method in a method call when I don't actually have to. So none of these things would break in Ruby. They would just probably mark you as a second language learner. Human languages generally fall into one of two categories, one in which pronouns are optional or one in which pronouns are required. And when the pronouns are optional, we call this pronoun drop. So in English, we can say, she eats ice cream, but we can't say, eats ice cream. However, in Spanish, we can do that. We can pronoun drop, no problem. In linguistics, we call this the null subject parameter. But I'm going to call it the optional subject parameter because I think it's a little easier to understand in the positive. So in Italian and Spanish, they allow an optional subject, but in French and English, the subject is required. According to this principle, the optional subject language is the superset of the required subject language. And studies of second language acquisition have shown that it's easier for speakers of subset feature languages to learn superset features than the other way around. For example, it's easier for an English speaker to drop their pronouns when learning Spanish than for a Spanish speaker to always remember their pronouns when learning English. So now, how might we apply this to programming languages? Well, here's one idea. So remember how we talked about the method calls with parens, so time.now with parentheses. So in Ruby, you do not need these parentheses to call this method. They're optional. But in JavaScript, you absolutely need these parentheses. Otherwise, you're just referencing the method and not actually calling it. So let's put this into the subset principle model. Let's call it optional parens. So if this follows, it would be easier for someone who learned JavaScript first to adapt to the optional parens of Ruby than for someone who learned Ruby first to always remember their parens in JavaScript. And I can say in my case, this is definitely true because I still make this mistake in JavaScript of not explicitly calling functions because I come from Ruby. Okay, so this is all very theoretical, but what is the practical application here? Well, the field of programming pedagogy is still fairly new, but identifying some concepts that are easier to learn than others, some truths that persist across languages, or some examples of first language transfer could be really helpful in this emerging discipline. So how do we teach language? This is a really big question, and the field of second language teaching has been around for a long time. But I picked out a few practices that I think we can directly apply to teaching programming. So this one is learner-centered instruction. This is an approach that developed in the 1970s and 80s, and it was a reaction to the one-size-fits-all philosophy that was dominant in language teaching up to this point. And this practice stems from the idea that learners are diverse. And this may seem obvious today, but it was actually really novel at that time. So if a learner is unique, there's no one solution that will fit every student. So instead of focusing on the subject, which is language, we should focus on the learner and what they need. So how do we know what a diverse group of learners needs? This is not a trick question. It's actually really easy. We just ask the learners, and we involve them directly in the decision-making process around their learning. So how can we make coding instruction more learner-centered? This is a good question, and we're going to come back to it at the end. Content-based instruction. This is an approach to language teaching that organizes instruction around meaningful content and subject matter. So it's in contrast to traditional instruction that focused explicitly on teaching about the language. This is teaching through the language. So here's an example. Let's say you're a teacher and you have a bunch of students who are interested in the environment and pollution. So for your lesson, you decide that they're going to read some background material about the environment, and then you're going to organize a debate where they're going to debate the best way to approach this issue and solve the problem of pollution, and then they write a journal entry about it. So the content is the environment and pollution, and you're using the language to explore that content. So what might content-based coding instruction look like? Again, we're putting a pin. We're coming back to it. Hang with me. We're going to get back to all of these. So the zone of proximal development is another theory in the field of education. And it's the distance between what a learner can do independently and what they can do with help from a more skilled counterpart. So drawing from this theory, we should stay in the middle zone. Because if we're too far to the left, the learner is bored. If we're too far to the right, they'll be lost. So there are some things that learners can't do even with help. They're just not ready in their phase of development to be able to do those things. So I know I went through the history of how I learned to code very matter-of-factly, but the initial few years I spent learning were extremely difficult for me. In my life, I was used to new concepts coming fairly easily. But this was the first time in my life that I felt like no matter how hard I tried, there were just some things that I could not understand. And it made me feel bad. Now at this point, I knew about the zone of proximal development, but I had not thought to apply it to my coding career. For example, you can't go from learning how to write a basic method to something like multi-threading, right? You can't understand the concept of multi-threading without first understanding concurrency. There's an order to the way you have to acquire these concepts, and you can't just skip around. And it's important that learners know this, so they don't feel stupid for not understanding something that they simply don't have the background to understand yet. And similarly, educators need to make sure to keep materials at the right level for their learners. So how can we keep learners within the zone of proximal development? Putting a pin on that. Oh, okay. We're coming back to the pins. So I know I put a lot of pins in these slides, and it's time to come back and discuss all of these questions and answers. So all of these questions that I've posed lead up to one central question, which is drawing from the principles of language acquisition and teaching, what might a pedagogy of programming look like? Now, I know most of us are not formal teachers of code, but I'm willing to bet that most of us do teach in some capacity. Mentoring and pair programming also count as informal teaching. And at the same time, all of us are learners. So if we remember way back to when we talked about first language acquisition, we discussed how babies develop concepts independently of language. They're using language simply to express the concepts that already exist. But when somebody's programming for the first time, they're learning both the concepts and the language simultaneously. So how can we decouple concepts from language? So here's one idea. Has anyone heard of this program, Scratch? Yeah, quite a few. So this was a program developed by MIT for people learning to code and so that they could develop games. And it provides a drag and drop interface to put together code blocks, kind of like virtual Legos. So here's what a code snippet looks like in Scratch. Let's take a closer look at that. So you can read, on the left, there's an if statement, and it's just in plain English. And the learner doesn't have to worry about syntax here. And they can fit in those little areas with other expressions, and you get clues by the shape and the color of all the different pieces. So I think this game is a really awesome learning tool. And then my only opportunity for improvement would be, can you localize it? Because we haven't gotten into the English language itself being a barrier for many aspiring coders around the world, but it definitely is. So if we can decouple syntax from concepts, why not go one step further and lift the burden of needing to learn English in addition to learning programming concepts? How can we make coding instruction more learner-centered? There's no one-size-fits-all for learning, so everyone learns in different ways. It's our responsibility to figure out ways that our learners learn best. We can figure those things out by getting to know each other. So learn about someone's goals and their background. Why are they learning? What motivates them? Don't assume you know the answers about any person because everyone has their own unique story. Once you've figured out what your learner is interested in, make a plan together. Make sure your learner has a direct voice in what you'll be doing. Ask them to create a list of goals that you can work on together. Are there any strategies that would help your learner? Maybe they like to read code out loud. Do they like to talk through a problem or sit quietly and think? Would they benefit from doing some solo research or diving right into a new concept together? Review what you've learned together. What worked? What didn't work? Is your learner meeting their goals? Where can you improve? If you recall, content-based instruction is learning a language through content rather than learning about the language. And content-based instruction aligns perfectly with learning to code. So how can we utilize this? So explain concepts with real-world examples. I'm sure many people are familiar with Sandy Metz's practical object-oriented design. And one of the things that really stuck out to me when reading this book is how Metz uses this extended example of a bicycle when explaining classes and methods in Ruby. So in this example, Metz explains creating a gear class and initializing the chainring and the cog variables. If we're just starting to program, we're much more likely to be familiar with a bicycle than we are to be familiar with a Ruby class. So Metz is building upon our existing knowledge of the world and mapping programming concepts onto that context. And this fits very well in the zone of proximal development, because explaining software concepts through real-life examples provides a kind of scaffolding so that we're not just jumping into concepts that we're not ready to understand. So both of these examples come from real Ruby learning websites, and they're both meant to describe what the collect method does. So take a look at that, and I want you to tell me which one do you think is easier to understand? Who says A? B? Okay, so 1 or 2 for A, but most people for B. So I would agree with you that I think B is easier to understand. And the reason is because we're pulling, we're stepping out of the abstract and into the concrete, right? We're keeping it super simple, and we're just returning the word cat 4 times. And it doesn't have to be more complicated in order to make the point. Has anyone heard of this software called SonicPy? Couple people? Okay, I just learned about this through my research, and I think it's super cool. It's a really perfect example of content-based instruction for coding. So it's a software made for writing music, but actually the purpose is learning to code through writing music. Here the content is the music, not the language. So we're using the language as a tool to create the music. I think there's this idea in the software world that if you like puzzles, you're going to be a really good coder. And I would like to tell you that I hate puzzles. Basically, like every kind of puzzle you can think of, I really, really hate it. So I know I'm just one person. Other people have different opinions. But I find puzzles frustrating, and they make me mad, and I don't think that's a good way to learn anything. Being able to solve a puzzle, though, is exactly what it sounds like. It's being able to solve a puzzle. And it's not what software engineering is really about, which is building and creating. So we should put the real context forward and use the language as a tool to create something. But don't just build anything. Find something that you or your learner is interested in and build that. If a big project is overwhelming, could you build a series of smaller projects with some unifying theme? This is an example of a project I really like by Jennifer DeWalt, who is teaching herself to code, and she decided to create 1 website a day for 180 days. And she was able to create all these little short projects around specific skills, but tie them together into one big project in order to sustain motivation over a long period of time. And I think that was very, very successful. All right, how can we keep learners in the zone of proximal development? So I'm going to throw out some ideas here. Not every idea will work for everyone, and that's fine. But if you see something you like, give it a try, because it might work for you. So pairing. How many people here pair regularly? Yeah, quite a few. Good. So pairing is a helpful tool for learning, because the sweet spot for a learner is somewhere slightly more challenging than what they can do alone. So pairing provides that kind of scaffolding to learn something more than what they already know. But think about who the learner is pairing with, because it's not always the best idea to pair with the most experienced person in the room, because the gap in knowledge can be too great. So sometimes it's better to pair with someone only slightly more experienced than yourself, or for your learners. That way the gap in knowledge is smaller and the step up is more attainable. Don't touch the keyboard without asking. You can ask, and then you can touch the keyboard. But generally, let the learner drive. So they won't learn nearly as much by watching someone else code as they will by coding themselves. Encourage discovery. Let the learner try things and make mistakes. So even if you know immediately that what they're doing is not going to work, don't say anything. Just let them go. Let them make their own mistakes, because once they fail, they'll understand exactly why, which is a much more valuable lesson than you just telling them from the beginning why something is going to fail. Check comprehension. So a lot of people, when they're working with a learner, they'll say, do you understand? And then the learner says either yes or no. So when they say yes, you don't actually know if they understand, because they might just be like, yes, leave me alone. But if they say no, your next question is probably something like, well, what don't you understand? And then that's a super hard question to answer for somebody who doesn't understand something, right? They probably won't even know where to start to answer your question. So instead, why don't we ask what they do know? So what does this method do? Where does that variable come from? Can you trace this code path out loud for me? Questions like these. Don't over-explain. So the more you explain a topic, the more likely you are to touch on some concept that a learner is not ready for. So just keep it short and sweet. And finally, beware of jargon. It's common for somebody who's learning to understand a concept without actually knowing the word for that concept. So if you use a word and your learner looks at you like, what are you talking about? Try just rephrasing it, because they might actually know what you're talking about. They just don't know the word that you're using. All right, so that brings us to the end of the agenda. We covered a lot of things. So what does happen when a linguist learns to code? Well, she starts thinking about all the ways to apply her former career to her current career, resulting in a talk like this. And I personally think that career changers bring a lot of value to software engineering by providing new ways of looking at familiar concepts. Programming pedagogy is really a field in its infancy. We've only just begun to teach coding in schools, boot camps, and online. Language teaching, however, is much older. And it's my hope that we can take an interdisciplinary approach and draw from this more established discipline when figuring out how to best teach programming. Thanks so much for coming to hear my talk. Feel free to get in touch or catch me outside with any questions. Thanks.